Okay, I'd like to welcome everybody to the first official module of the CompuCell workshop this year. I'm James Glazier, Professor of Intelligent Systems Engineering here at IU Bloomington. And I appreciate all of you being willing to come and spend a week with us virtually. I'd like to thank our supporters over the years from NIH and NSF in particular. And I also need to remind you that this session, as all the sessions, will be live streamed on YouTube, recorded, and made publicly available. Today, we are going to go over a little bit of the course logistics. Some of you have seen this before. Some of the material we'll cover today was covered in the orientation session a few weeks ago, but not everyone will have had a chance to see that. And then we will begin to start using CompuCell. In this session, we'll just run a few example programs. We're not going to dig in too much detail into CompuCell, how it works, how to write modules, but that will be started in the next session. As always, we have everything by Zoom. Please do feel free to use your, the raise hand button, go slower, go faster buttons. We'll try to monitor those. Please also use the chat and let us know if there's anything that you're having trouble with. As was mentioned before, we use polls quite a bit to make sure that people are on sync with each other. And it's important that you have the latest version of Zoom client loaded on your computer so that the polls will work properly. And the other thing that we ran across yesterday is please don't wait to tell us if there's a problem. If you have a problem, tell us immediately and we'll create a breakout room and move you into the breakout room. Don't wait an hour to say that you weren't able to get into nanoHUB or that something happened and you weren't able to keep up. It's much easier for us to help you if you tell us immediately that there's a problem rather than waiting. We have plenty of people here who are eager to help out. Don't be shy about saying slow down. Don't be shy about asking for help. As far as the people going to make this course happen, we're grateful to them. We have a lot of volunteers. Besides myself, TJ Sigo, Gilberto Tomas, Julio Belmonte, Priam Adjapok, Pedro Del Castel, Jim Sluka, Joshua Ponte Serrano, and Bobby Manamanchi are all helping out, lecturing. And Hayden Fennell, who's organizing this year. Connor McShaffrey is going to help with the hackathon. Joel Vannon is going to also help with the hackathon. And Lorenzo is also going to be helping with the hackathon and during the course. We're very grateful to everyone for their help. I don't know, maybe if people want to maybe just show their faces if they're online. I see Hayden, you're there. Julio, start with Julio. Julio, I think you actually, to be visible, you have to probably unmute and say hello.
Hello.
Hayden, maybe?
Yeah, so hello everybody. A lot of you were just listening to me for the past 15 minutes, but I'm Hayden Fennell, the organizer of this year.
Gilberto?
Okay, I am Gilberto, I'm here.
TJ?
Hi everyone, TJ. Nice to meet all of you and very much looking forward to working with all of you this week.
I forgot to mention I'm this year the main contact for issues and things like that. So if you have problems, please send them to me and I will forward them to the correct parties.
Lorenzo? Okay, well, you can come in.
Maybe Lorenzo's power went out instead of ours.
Pedro? You have to unmute for people to be able to see you.
This is not a bongo, okay? This is a drink. It's a drink from Brazil. Don't worry.
You have a mate, right?
Yes, exactly.
Right.
It's a tea,
All right.
basically.
Okay, so you've met a few of the people, and again, we appreciate everybody that's volunteered. As you've seen before, our daily routine will be that we'll start around 9:45, being online, making ourselves available. If you have questions, want to talk, that's fine. We'll have the two first half of the day modules of an hour and a half each with a short break in between. We'll have a midday session, which will be devoted to organizing the hackathon, troubleshooting, other things of this kind, followed by lunch, 2 afternoon sessions, and then the opportunity for more questions or concerns after the main sessions are over. And that rhythm will be the one we'll follow for the whole week. Today, we're going to start out with this lecture, which will just be a basic introduction to using CC3D. As I say, this will repeat some material that people have done if you took the orientation a few weeks ago. So we have a large number of people registered. Not everybody, of course, who's registered will show up on any given day, but we will do our best to support you. Please be patient. If you're an experienced CompuCell user, there are a few people here who are here for multiple times, and you're willing to help mentor beginners, please do let us know. We'd always appreciate help with that. Workshop resources, the CompuCell website for downloads. The CompuCell website has a link for that as well. There are the online manuals, and those have some very useful materials. There is something called the CC3D Quick Start Guide. It's quite old, but almost everything in it is still up to date, and we certainly recommend that. We have the Slack channel, the course Google Drive. We'll try to put all demos up on the Google Drive for you. If anybody has trouble finding them, please let us know. For antimony and tellurium, there's a great online Read the Docs manual system for that. There's a CC3D quick reference guide, and there also are the Python cheat sheets and the tellurium antimony cheat sheets that we've distributed. We strongly recommend that you print out hard copies of the Python, tellurium, and CompuCell cheat sheets / quick reference guides. It's very useful to have those on a piece of paper so that you don't have to keep flipping back and forth between screens on your computer. As Hayden mentioned, we have a Slack channel. Please use that. We'll try to monitor it, but fundamentally that Slack channel is there for you. And so its usage is really dependent on how the community evolves. As I mentioned, the quick reference guides are really helpful. That Python quick reference guide is a lifesaver if you're not an experienced Python programmer. Even if you are an experienced Python programmer, it may have some tricks on it that you're not familiar with. The first 2 pages have the basics, really very valuable material. CompuCell quick reference guide has all the basic commands and things that you'll need. We'll come on Wednesday and Thursday to using antimony and tellurium to do subcellular modeling. All of that material is available there as well. It certainly doesn't hurt to review these things before classes. If you would like to learn a little bit more about the details, because we're not going to go into a lot of details about the under the hood parts of CompuCell, there's an older paper that we have shared in the course readings material that I think is quite good on the history of this modeling methodology. And then If you haven't done mathematical modeling at all, there was this group of Canadian students who wrote a very nice general paper on the principles of mathematical modeling that I recommend. There are some differences between what they do and what we do, but it can be quite helpful, I think, if you're unfamiliar with mathematical modeling. Nobody comes to this kind of course knowing everything unless you've been teaching it, and even then there are things we don't know. There are a large number of resources available for different aspects of the issues that you need to know. One of the problems with this kind of mathematical computational modeling is that you really need to know a little bit about a lot of things. You don't necessarily have to be a specialist in any one area, but it is very helpful to know some background in a variety of areas. You need to do a little bit of Python programming. If you want to learn about network modeling, we always recommend Herbert Sauerow's textbook, Systems Biology, Introduction to Pathway Modeling. Herbert taught a great online course 2 weeks ago, and I strongly recommend that people look at that material online if they like. For basic mathematical biology, which we'll minimize in this class, a good textbook is Britain, Essential Mathematical Biology. I'm a big fan of learning biology through Gilbert's developmental biology textbook. I always recommend the older editions. You can pick them up for $2 or $3 online. They have all the same basic methodologies in them. They just don't have as much molecular detail. They're much better actually for learning. To begin with, if you want to know about biophysics and how the underlying biophysics of cells affects the way they do behave, I strongly recommend Phil Nelson's Physical Models of Living Systems, which is a nice introductory textbook in this area. A more advanced textbook, very, very beautiful, is Physical Biology of the Cell by Phillips and colleagues. We've mentioned our paper as an introduction. There's also a nice book by Scianna and Preziosi on this kind of modeling. It's getting a little bit old now, from 2013, called Cellular Potts Model, Multiscale Extensions of Biological Applications. It's a great textbook. And if anybody has suggestions for additional materials that you think would be good to share with people who want to learn this kind of thing, we would very much appreciate it. So we're going to just say a few words about motivation for multicellular modeling. Really, this will be covered more in the midday when I'll talk a little bit about examples. Fundamentally, and you'll see this slide many times. In fact, anytime I give a talk, I'll show this slide. Our world is multicellular organization. And so that multicellular organization could be problems in development. How do tissues and organisms develop from an initial fertilized egg? How is patterning done? How do you build the complex structures that compose our bodies? Once you've built an organism, that organism isn't static. It needs to be maintained. The cells in your body are replaced. The cellular components in your body inside those cells are replaced. And so homeostasis, the maintenance of organization, is actually a very complex problem. And as we know, we all age and die. So homeostasis fails. And one of the ways that it can fail is by having the mechanisms that are normally employed to build and maintain the organism become dysregulated in some way and lead to pathologies. The classic example of what we would call a developmental disease is cancer. And many people in this audience will be interested in cancer modeling, but we'll find that there are many other kinds of developmental disease as well. At some level, things like arthritis and other degenerative diseases are developmental diseases. And those are things that are going to be of interest, I think, to a significant number of people. You can use this kind of modeling to understand infectious diseases and immune response. and that's an area of interest. You could use this kind of modeling in the context of biomedicine in terms of treatment discovery, treatment optimization, and you can certainly also model living tissues that are not inside of organisms, whether you want to model cells in a dish, organoid culture, potentially bioengineered tissues. Always, we have to remember that biology is a complex interplay of physical and biochemical mechanisms. And the current world of biology is very molecule focused. It's very much focused on parts lists of molecular components. However, we need to remember that if we don't have physical ways of translating that biochemistry into action, knowing those molecular components by themselves doesn't really tell you much about how things work. As I like to say, if you know a list of all the parts in your car, it doesn't tell you how well the car drives. So we're going to be talking about what we call virtual tissues. What are virtual tissues? Mechanistic simulations. These are going to be essentially equivalent of computer-aided engineering studies of living organisms. It's a rapidly engineered field, a rapidly developing field. Ultimately, we'd like to be able to build more detailed models that can be used in biomedical prediction. How we're going to do that is something we have to think about. We're going to be dealing with a variety of length scales in biology. There is no single computational approach that will work for all biological problems. You could have molecular dynamics simulations focusing on how individual atoms and molecules work. In that case, you can't even model a single cell completely, or even a second of time scale. You could have continuum mechanics models of the bones in your body or the heart that don't include individual cellular behaviors. And so there are all going to be a whole variety of different mathematical and computational methods that are going to be used in different contexts. One of the things that we have to deal with in the world that we're going to live in, especially if you're dealing with development, these are videos of developmental biology of a variety of kinds, is that cells move. And the cell movement is something that many modeling methodologies don't handle well. We'll also deal with the fact that cells have complex shapes, and that's something that CompuCell does to some extent. There are other modeling methodologies that are more focused on that. There are others that are less focused on that. In this case here, we have an in vitro example of branching morphogenesis of kidney tubules. Actually, I think this may actually be lung rather than kidney. Check that. This is a SPIM image of all of the cells in a developing zebrafish embryo in early development. This is a video of chick embryo developing its segments, its somites. And then this last image is of blood vessels developing in the mid-body of a developing zebrafish embryo. In our world, for virtual tissues, we're going to be living at the level of cells and moving above and below that. And there's a very practical reason to use cells as your organizing principle, and that is that cells are the primary active agent inside your body. They're the things that are going to do things. They may organize into larger scale structures like the heart, which functions, of course, as a pump. And you could think of the heart as an agent in its own right. But in general, while extracellular structures like extracellular matrix are going to be very important, and they can, in fact, have active properties, the primary agents of activity in your body are cells. And so we're going to be thinking of what we call multicellular models, where we're going to be simulating individual cells. Sometimes our simulations will go down and look at components of cells, and Gilberto will certainly talk about that, and Julio and Priam will talk about that. Sometimes we'll go up and we'll say that one CompuCell cell represents 10 real cells or 100 real cells, a little cluster of cells. But fundamentally, we're going to be focusing on multicellular organization. And the core of CompuCell is going to be a simulation methodology to simulate how individual cells behave and interact. We're typically going to assume that those cells have control, and we're going to assume that those controls come from networks, gene regulatory networks, metabolic networks, cell signaling networks. We're not going to model the complex macromolecular machinery inside cells in detail. We may build abstract representations of things like leading edges, lamellipodia, or filopodia, but we're not going to model individual actin filaments or individual microtubules in their organization. We may often do compartments, for example, having nuclear compartment or cytoplasmic compartment. And again, Priam and Julio will talk about that in some detail. At higher levels, cells send out signals. Those can be mechanical signals, they can be contact signals, they can be diffusible chemical or electrical signals. And so we're going to have a concept of fields around cells, where cells secrete and absorb and respond to fields. And then we're going to have cells change their mechanical behaviors to reorganize. And this is based on that chicken simulation we saw chicken experiment we saw a minute ago. This is a simulation of the pre-Semitic mesoderm. You have a set of genes that oscillate inside the individual cells. They interact with a gradient of a morphogen, which is high in the tail of the chicken and low towards the head. When that level goes below a threshold, those cells will differentiate in response to the environment, change their mechanical properties, and mechanically reorganize to form somites. We often also will put all of this inside what's called a PBPK, a pharmacodynamic model of blood transport and chemical transport, elimination, and distribution in the body. And that's particularly useful if you want to understand, for example, drug delivery or drug elimination or toxicology. And so we'll have typically 3 and possibly 4 levels of model. We'll almost always have this multicellular level. We'll often have a subcellular control level. And we'll always have a local environmental level. And sometimes we'll put that inside of a whole body non-spatial model. These are going to be mechanistic agent-based models. That is, we're going to be modeling individual components as independent agents. We're going to be focusing on emergent spatiotemporal phenomena, what those agents are doing. It's going to be mechanism-driven modeling. We're going to have reasonable hypotheses about what those agents do, how they interact, how they behave, how they change. These are additive models. It's the opposite of bioinformatics, where you start with everything and filter. We're focusing cells to organism level. And we're going to need always to be thinking about what the submodels of our object behaviors are. What causes cells to be created? When do they die? Under what circumstances? What does that death do? What forces do they generate? How do they change shape? How do they move? Why? And our outputs are going to be movies, typically. And one of the things that we have to think about carefully when we're going to apply these methodologies is how do we interpret those movies to come up with something that's meaningful. One issue we'll face is that biology is stochastic. If you had the identical situation run twice, you'd get different results. And so how to interpret movies and time series is something that we have to think about in the context of the particular problem we're trying to solve. We're going to go over a lot more examples a little bit later. These are a couple of classic examples that we've developed over the years. We'll talk about them in a little bit more detail. This is polycystic kidney disease. It's a proliferative disease, classic developmental disease. These are some nice old simulations of cancer growth, which we show a lot. This was an attempt to do optimization of therapy for diabetic retinopathy. And this was a study of the mechanisms of a different retinal disease as well. You'll see that in at least 3 of these cases, we are dealing with cell proliferation. And in 2 of the cases on the right, we are also dealing with large-scale cell migration. And that's typical of the kind of problem we're facing. Building these kinds of models is not easy. Biology doesn't make life easy to interpret. There are lots of components. You have literally large numbers of cells and tissues. The number of types of cells is large. Those cells have rather complex behaviors. They're not trivial to understand. And they're not always predictable or uniform. 2 different cells of the same type may behave very differently, even under similar conditions. And the way the cells behave changes when you put them in a different environment. Something that's really important is that there's a tight coupling between elements. It's not only that cells respond to their environment, but cells change and create their environment. And so you have a situation where cells are creating an environment that they respond to themselves. And that tight coupling is why this kind of modeling is essential. It's why methods like artificial intelligence really don't work very well in these kinds of contexts. AI is wonderful for interpolation, but it's not very good at extrapolation outside of its training domain. The range of lengths and timescales is very large, and there's a lot we don't know, scientifically and otherwise. And so we have a lot of things that we have to face, and limitations and difficulties that we face when we apply these methods. There are many different ways to represent cells. They have a variety of advantages. A variety of advantages and disadvantages. Please try to mute, unless if there's an urgent question, please feel free to ask, but please remember to mute if you're not talking. Otherwise, the Zoom gets a little complicated. These could be everything from cellular automata, where you have point particles in a lattice, center models, which are based on molecular dynamics methods, which allow you to do very large numbers of cells, but with no spatial detail, up to detailed finite element models, where you have a lot of spatial detail, but the computational cost per cell is larger. And there's a nice book from a few years ago, single cell-based models in biology and medicine, that reviews a lot of the different methodologies that you could use. If we were just going to look at some of these are center models. These are all based on molecular dynamics. This is a package called PhysiCell, developed by Paul Macklin here at IU, Bloomington. He taught a course on this method last week. Biocellian from Pacific Northwest Labs allows very, very large-scale simulations. Chased from Oxford in Australia. So there are many different methodologies, all of which have wonderful advantages and disadvantages. There are what are called vertex models, which are great for modeling sheets of cells and have some very specific advantages for that. These are more classic finite element models. These are some beautiful work of Karniadakis modeling blood flow, where he's modeled the mechanics of each blood cell in detail in the fluid. That has some real advantages in terms of its realism. It also is incredibly computationally expensive. So there's always going to be a trade-off between the level of detail we use and the level of specificity in the models and the speed and size of the simulation. We're going to be using CompuCell. It's a virtual tissue simulation environment. It can run on Windows, Mac, or Linux, but in the context of this course, we are going to be running it on nanoHUB. And nanoHUB version has some disadvantages. We're going to run into those pretty soon. But it does have one great advantage, that everybody sees the same thing. And whatever your computer configuration is, it'll work the same. And for teaching, that's really very valuable. CompuCell has two core components, a model editor called Twidit, which has a lot of features to make it easy to build models, and a simulation execution engine called Player that allows you to visualize, run, make some changes to the model as it's running. CompuCell supports a bunch of core concepts on the computational side that try to map biological things that we need to do. We've talked about cells. The general concept of a generalized cell is simply a volume of material. That is, a generalized cell could represent a single biological cell. It could represent a subcomponent of a biological cell, like the nucleus or cytoplasm or apical domain or basal domain. It could represent a cluster of cells. Or it could also represent a little bit of material, like a little parcel of fluid, or a little bit of extracellular matrix, or a mechanical substrate that the cells are sitting on if you're doing a tissue engineering experiment. Chemical fields, or electrical fields, or vector fields are things that we've talked about. We have a concept of links. Those links can be used to build representations of things like junctions between cells, or filopodia, or solid materials. And we have a concept of networks. And these are the core elements that we're going to be using again and again in this course. The order in which we'll cover them will be cells first, and fields next, the interaction between cells and fields, and then dynamic networks and how they can be connected to cells and fields, and then finally how to build compartmental cells. These are going to be network models, and we're going. Excuse me, I said network. Lattice-based models, and we'll talk a little bit later about how we represent cells in CompuCell. So the first thing that I would like people to do is just get your feet wet, running an exercise on CompuCell. I realize that many of you have done this before, but not everyone here today has gone through the orientation beforehand. And so I'd ask everyone to follow along. You've heard me say this before, I'll say it again. We're going to use polls to make sure that everybody is keeping up. Please, when I launch the poll, it will ask you whether you're done, need more time, need help, or not doing exercise. And if you are done, click done. If you need help, click help right away. Raise your hand. If you're not doing the exercise, that's fine. Say so right away. But don't click the need more time button unless it looks like we're moving on to the next step. And the reason for that is a practical thing about polls on Zoom. That is that you can't change your answers in a Zoom poll. And so once you've clicked need more time, there's no way to say that you finished the exercise. And so please only use that need more time button when you really need more time. When I say, is everybody done? That's when to click need more time, and I'll give you more time. Just as a logistical. Okay, so what I would like everyone to do now is to migrate to see nanoHUB. And we're going to start out by running that vasculogenesis simulation. This is a demo that's packaged with CompuCell. CompuCell comes with a number of demonstration programs that you can run relatively easily. Sometimes I think we should probably have better ones, but I'd love it if people would like to contribute their models to that demo suite. This is going to be based on work primarily done by Roland Burks, who was a student of mine then, a postdoc at that time, a long time ago, now a professor of mathematics at Leiden University. studying the basic mechanisms of vascular development. In vasculogenesis, you have individual precursor endothelial cells that are going to spontaneously self-organize to form blood vessel networks. The same kind of cells show up in developed blood vessels and can lead to what's called sporadic angiogenesis. And one of the questions back 10 or 15 years ago was whether the same mechanisms could work in both the angiogenesis and vasculogenesis. And so in this simulation, we're going to have just one kind of cell, endothelial cells. We're going to be thinking about modeling cells in a dish. We're going to assume that the cells secrete a chemical. It's called vascular endothelial growth factor A. Details don't really matter at this point. And that they move up gradients of that chemical. They move towards higher concentrations. And we're also going to make an assumption that when the cells are touching each other, they don't see the gradient. There are surfaces where they're contacting don't respond to the gradient. That's called contact inhibition of chemotaxis. And this was based on experiments by our collaborators at the University of Kansas Medical Center that showed that in the chick, if you blocked the adhesion molecule that prevented chemotaxic signaling on contact, instead of getting vascular networks, you got blobs of blood vessel cells. And in fact, this is the simulation that we did at the time. These cells are both secreting a chemical. You see the color gradient here. They are chemotaxing, they're moving up gradients of that chemical. In one case, all surfaces of the cell respond to the chemical. In this case on the right, only the surfaces that are in contact with the medium and not with the cells that with other cells respond. This was a movie by Davide Ambrosi from Italy, where they did experiments using a human umbilical vein endothelial cells, showing this patterning organization that occurs in vitro. And that's the simulation that I'd like people to run now. And so I'd like people now to go to the CompuCell application on nanoHUB. So that would be https nanohub.org tools CC3D base 4x. And let's see, where's my chat? Can I ask, Hayden, if you're here, could you paste the link for the nanoHUB app into the chat for me? Or Gilberto, could you do that for me? So I'd like everybody to go to the nanoHUB application. We're not going to walk you through logging into nanoHUB every time, but for today, we want to make sure that everybody, thank you, Kate. I want to make sure everybody can get into nanoHUB, go to nanohub.org, hit login. Hit login, and you have a variety of choices here. If you haven't logged in before, hit sign up. And under sign up, you'll have three options. If you're within an American institution, you can log in through your institution here. This top one, sign in with an affiliated institution. If you're not with an American institution or you want to use your Gmail account, you hit sign in with Google and you can get in automatically. If you don't have either an American institution or a Google account, the login will give you an option where you can simply type your name and your internet address and other things. I would prefer everyone use nanoHUB, was the question. If you want to do it on your, if you want to do this on your local machine, that's fine. If you want to run locally, that's fine. but it won't look exactly the same. There certainly are some advantages to running locally, but I would encourage people to begin with to start on nanoHUB. It depends a little bit on your level of experience. If you're more experienced, that's fine, and run locally is great. But we're going to assume that people are on nanoHUB. And so we're going to be primarily troubleshooting problems from the point of view of nanoHUB. Okay, so I'd like everybody to sign in. And so I need to make sure before I go any further, I'm just going to make sure that everybody is available on nanoHUB. So I'm going to log in. In my case, I'm in Indiana University, so I can log in through Indiana University. Okay, somebody says they need help. Could the person who... That's right. At the moment, it's just a question of, and if you're running locally on your laptop, it's fine. Don't worry about it. The key thing is I want to make sure everybody has CompuCell running somehow at the moment before we go forward. So the person who said they needed help, could they raise their hand, please? Manali, is there a problem that you think that we should address as a group, or do you want to go into a breakout?
I have logged in, but
Yes.
When I'm trying to connect, it is showing select group.
Okay, is anybody else having trouble?
I have that extra version also. I will use that.
Okay, in that case, I guess using the desktop for the moment will be your best bet. And we'll try to troubleshoot that during the break, okay? Is anyone else having problem? I'm going to do the poll again just to make sure that we have, if people need more time, that's okay, just tell us. Could the people who said that they need more time raise their hands? Lily, is there anything we can do to help you out?
No, I'm just going through the steps of logging and everything. Yeah. I haven't logged in before, so.
Okay, great. Okay, so you'll have time to catch up in just a second here. Once you've logged in, you should see a nanoHUB dashboard. And again, we'll do this again, so you'll have plenty of time to catch up. The nanoHUB dashboard will look something like this. You can return to it by hovering over the thing that says nanoHUB in the top left, or on the top right, there also are going to be under where you say logged in, you can select dashboard here, and that'll take you back. The nanoHUB interface is not the most sophisticated in the world, and we'll run into a couple of minor annoyances with it, but it is basically pretty robust. Okay. So the next thing we're going to do is actually just run a simulation using CompuCell Player. And the first thing that I'd like you to do is to launch CompuCell. And there are a variety of ways that you can launch CompuCell. Yes, Pedro mentions nanoHUB is a great way to publish your models. If you write a model, you can put it up on nanoHUB, and that gives you a DOI. It's not a refereed paper, but it is counted as a publication. It's got a persistent link. And I use this for my undergraduate teaching. The students post their class projects as nanoHUB applications, and a number of them actually have gotten jobs at places like Google or Facebook on the strength of being able to point to the nanoHUB app that they wrote to show their coding. Because it's hard if you have a CV which says you can code, it's difficult to demonstrate what you're able to do. If you can send them a link which actually has a live program, that's pretty nice. So to launch CompuCell on nanoHUB, we have a number of ways of doing that. One of them is to navigate directly to the CompuCell application, and I'll show you how to do that in a second. The other thing to do is to go to My Tools, click on All Tools here, and now we can type the name of the application, CompuCell3D. Helps if I spell it right. And it will pull up all of the things that have CompuCell3D in their names. And the one we want is called CompuCell3D V4, like that. And you'll see CompuCell3D V4 main tool. And this little heart button here allows you to bookmark the tool. So I recommend clicking that heart. If you click the square box here, that will launch the tool. You could also search on My Tools or go directly to the launch tool. And I'm going to put the link to take you directly here in the chat, which is also helpful. So I want to make sure that everybody has CompuCell running. Again, if you're doing it on your desktop, that's fine. Things will look a little bit different. Again. And I realize that this may be a repetition for some people. If it's a repetition for you, I encourage you to go and explore the demos that are available in CompuCell. As much as possible, we're going to try to have a base set of exercises that are what you need to go on to the next exercise. And we'll try to suggest for people who get through it a little bit faster, we'll try to suggest things that you could do to learn and keep interested so that you're not sitting waiting for other people to complete. The goal here is to make sure that everybody is successful, and we don't want people to be bored, but we also don't want people to be lost. And so what we want to do is have everybody complete the basics, and then people who can get through things a little bit faster will have some additional material that can come.
We have a question in the chat. Is there a group in nanoHUB? Is this related to the same issue that Manali was having?
I'm not sure what that means. I've never seen that group. I don't think you should have to elect a group.
May I speak?
Please go ahead.
In your screen at the bottom right, it is saying select group. This is the screen that we are encountering.
Okay, you don't have to do that. Just ignore that.
It's not getting us started, meaning we are just on that screen.
Ah,
So the CompuCell window is not showing, but you can see the rest of the screen is what you're saying?
No, we are seeing the entire screen, like the CompuCell main tool and the group, both.
Right. So you don't have to do anything with the groups. That's just if you want to share the
Okay.
simulation with other people. That's totally optional.
so
Okay.
just to make sure, is anybody else stuck there? Because this should not require you. This allows you to create a share, but it's not required. So are you seeing the screen that you see here, or are you seeing something else? Are you not able to launch CompuCell? Is there anyone, maybe I should do it this way. Is there anyone who is not able to launch CompuCell at this point? Please raise your hand. Okay, looks like everybody. Okay. Okay, so what you'll see is this blue screen, and inside it you'll see player. Great, good. And what we're going to do now is run a simple simulation. And we're going to use the existing demos that exist. And what we are going to do is, first thing I'm going to say just is that one thing you may find is, especially when you're using Zoom, that the response of nanoHUB may be a little bit laggy. But you could manipulate the size of your sub-windows with the usual tools to make things more visible. One thing that you may find, I'll come back to this, is that occasionally you'll have misdrawing of the screen. If that happens, grab the bottom right corner of the bounding box. And as I say, sometimes it gets a little bit laggy when you're running Zoom, and move it, and that will force a redraw to clean the screen. Okay, to open a simulation, we go to File here. We pull down File. We set Open Simulation. It will give us a set of options here. We have to first click on our username here. And then we will find a package called CompuCell3D demos. And because I have a lot of simulations already running in my workspace, you shouldn't have all of that extra material. Select CompuCell C3D, CompuCell 3D demos, and open that. And you should be able to find a variety of options here. And it looks actually like they may have changed a little bit from the ones that I had before. I have to open demos again. Book chapter, angiogenesis, CC3D. So I want to make sure that everybody can find that and open.
Yeah, so so after clicking the CompuCell, the demos, which folder did you click again?
Okay, so go to your name first.
Yep.
And then you should find CompuCell C3D demos.
Yep.
Let me walk us down the tree because it's a couple of levels down. I have to click. If you go to computer, you may find it, but that's not editable. So you have to go to your name first.
Mm-hmm.
I have to find it. As I mentioned, I have a lot of things here, so it takes me a little while. CompuCell CompuCell demos. And then here, under that, I'm going to go to demos
Demos.
again.
Mhm.
Oops, I just went to the wrong one. So, demos. And then this exists actually in a number of
Book
places.
chapter.
Book chapter is the one I'm going to use.
Oh, okay.
And then angiogenesis.
Oh, okay. Thank you.
Does anybody else need help finding that? Raise your hand if you need help. Thank you for speaking up. Okay, and then I select angiogenesis.cc3D and double click on that. And it should now run, and to run it, I hit the run button here. So everybody should see something that looks like this, more or less. You have four control buttons here at the top. You'll have a button like a cassette recorder that says play, and say run, that will run the simulation. The button that looks like a record button in an old cassette recorder, the circle on it is step, single step. The two lines is a pause button, and that's one you'll use a lot. And the square box is a stop. The difference between pause and stop is if I hit pause, I can single step my simulation or I can run it again. If I hit stop, that terminates the simulation. And if I want to do anything, I have to start over. It'll set up a new simulation. And there is the minor annoyance that the window may resize when you restart a simulation. So I recommend not using the stop button unless you need it.
I have a question.
Yes.
The scale of my simulation is off. It's zoomed.
Yes. So I'll come back to that in a minute. You may have to do some resizing of the box. Yes. And I'll show you how to do that. Just a second. Somebody says that they got a server disconnected message.
That's
So
James, because they're running the old 4.2.5 simulations. They're in the wrong folder.
okay. Anybody else having problems here? Somebody said, where is the angiogenesis file? Again, go to, I have to hit stop. To find the file, you go to open simulation, your name, CompuCell demos, book chapter, angiogenesis. Everybody got it now?
Just as a note, we were having an issue earlier where nanoHUB CompuCell opens by default to the 4.2.5 window. So you may see the demos in the folder that you opened by default. That will be the wrong folder. You need to make sure to click on your personal drive first and then navigate to the demos from there.
Yeah.
That's why you're getting the server disconnect error, because it's trying to run incompatible code.
So let me do that one more time then. That's what, okay, to be very clear. When you do open simulation file, if you click computer here or leave it in the default, this is the root directory and you don't have write privileges there. So you have to open your local copy. So you have to click your name here before you start. Okay? So let me walk you through that again. CompuCell3D demos, book chapter, angiogenesis. Okay. Once you've done it once or twice, I hope it will become more natural. I'm just checking to see if there are any other questions. Okay, so we should have that working. And so now if we hit step, we will see the simulation run one at a time. There are a couple of things that you might want to do for visualization. You can control whether you visualize in 2 dimensions or 3 dimensions by selecting this pull-down menu here, 3D versus 2D. In 2D, you can select what plane you're going to visualize in. If you're in 3D, you can rotate and use your mouse to zoom on your simulation. So why doesn't everybody play a little bit with that? If you have a problem and you hover over the graphics window and you type the letter R, that should reset the graphics window to its default configuration. So why doesn't everybody take a minute? You can run the simulation while it's going. Take a minute to actually run the simulation.
But so that we've got a couple people still having issues. If you would like to join my breakout room, we can take a look at those while James moves on.
So now that you've got this, people have it running, I hope, you'll see that there are a lot of options for how to visualize. And again, you don't have to follow all of these now, but it's good to explore them. If I click on visualization here, I have the option for turning on cell borders or not turning on cell borders. I have the option for visualizing the cells or not visualizing the cells. Normally, I want to see the cells. I can zoom in and zoom out and so on. You'll find that sometimes that it's easier to hit pause before you start playing with things. But it should work even when the simulation is running. So people should play with this a little bit and see what they can do. The other options that you have are under the configuration menu. And I could go here where I have, it's a little picture of a screwdriver and a wrench. If I hit configuration, this will open a variety of menu options. There's a tab called output for saving my models results. There's a tab called general settings. And there's a tab called cell colors. And so if I decide I don't like the blue cell color, I could click on the cell color and pick another color. So everybody should be able to do that. I could also change the border color. And depending on whether I'm in 2D or 3D, that may be useful or not. In 3D, if I go to the 3D options, I can make certain cell types invisible because I want to be able to see inside of things. And so I may want to be able to make a cell disappear so I can see through it. And I can do that there. So I'll give everybody just a minute or two to play with the visualization here.
Can I change the number size and the letters?
That I do not think you have a control over. That would be nice to have. That would be a good thing. If somebody wanted to add that to our code, that would be great. The fonts are not user controlled. Are people still having trouble launching the simulation? Hope people are able to get it to work. So here we changed the color. So we did that one already. The other thing that's interesting is remember that, so if you're having trouble zooming out, you could use the rotate button on your mouse to change the scale. You could also go under visualization and do zoom out. And you could go under visualization and do reset camera.
I'm not sure why, but neither of those are working for me. Is there anything else I can try?
Are you on nanoHUB or are you on desktop?
On nanoHUB.
You're on nanoHUB and it's not doing that. And you're running CC3D v4.
Yes.
That one I really genuinely don't know. Is anybody else having this trouble? It's the first time I've heard this. I believe you absolutely, but it's the first time I've ever heard this particular problem.
There is another way to zoom in and zoom out, which, if I'm not mistaken, you can click with the right mouse button and drag.
Yes, you can always recenter this way with the right mouse click. Yes.
The right mouse, or try the left one maybe. No, the left one rotates. No, it's not it. I don't remember.
The dragging it with the right button on the mouse and then resizing it worked. Thank you.
Okay. Okay. That's why I want to give people plenty
Nice.
of time to play, because we have to discover all of the problems. Anybody else having issues? Another thing that's very useful is a feature is if you go under Window and you go to Tile, that will lay out the screen for you. And that's a very powerful feature. That does not work on desktops for Macs, which is one reason that I prefer to use the Nano. The other thing that I wanted to show you now is a button here. I could either go under Window and select New Graphics Window, or I could push this button here underneath the Window button, which says New Graphics Window. And this will create a second visualization window. The layout may not be so good, so that I can go to Tile and lay them out. And as I mentioned, in angiogenesis, we have not only the cells, which is what we've been observing, but also a chemical field, VEGF. I'd like people to go here, cell field VEGF, and now you'll see the chemical concentration of the molecules that these cells are secreting. And when you create a new window, or change the setting of the window, it'll pause the simulation. You have to hit run again. So why doesn't everybody see if they can see both the cells and the chemical field simultaneously? Okay, if somebody needs help, please raise your hand and we'll put you in a breakout. If
Sure,
you're-
maybe you join the breakout room with me. Let me see if I can help you.
Who's speaking?
Pedro, James, and Sharon. Somebody says clicking new graphics window doesn't seem to create a new window. James, are you on desktop or on nanoHUB?
I'm on nanoHUB.
Okay, so you selected a new window and it didn't do it. You try hitting tile, seeing how many windows you have. What did it do?
I'll only get graphics 0 for Windows when I press that.
I'm sorry, I didn't catch that.
Oh, sorry. Only graphics 0 and the cells one, the original is the only thing I see when I press.
So you just see one. So you're not getting a second window.
No.
Anybody else? And you're definitely running CompuCell3D V4.
Yes. Yeah.
Okay. Anybody else having that problem? I'm afraid that my solution to that one is going to be to suggest that you kill this the instance that you have by hitting terminate and relaunch CompuCell.
Right. Okay.
If it still doesn't work after that, we'll try to troubleshoot it. Anybody else have a problem with this?
I have converted into VEGF in the new window, but still the image is not changing.
So you hit run again?
Okay.
You have to hit run. When you change the layout of the windows, the simulation will pause and you have to hit run again to start it. So another thing you might want to do is you could visualize the chemical field in 3D as well. And you could see what you could explore that. Okay. The last thing that I want to do, which I think is pretty important, because you're going to have to do it a lot. And this is the one thing we can, the things at the end of this class that we can let go, but this is critical, is uploading and downloading CC3D simulations from nanoHUB. So it's going to be very critical to be able to load and unload files from nanoHUB. In particular, one of the annoyances, there are two annoyances, major annoyances with the nanoHUB CompuCell. One of them is that when we use the editor in nanoHUB, we can't cut and paste to the editor, model editor. We can cut and paste within the model editor, but I cannot put something in the chat and have you cut and paste it into the simulation. And that's a technical limitation with the way the nanoHUB servers work. So that means that we're going to need to be able to upload and download files from nanoHUB. And what I suggest you do is that you use Jupyter Notebook, which we taught yesterday if you took the Python bootcamp, as a way of uploading and downloading files. If you're running on the desktop, this is something you don't have to worry about. You can play with visualization while we're doing this. So what I would like people to do is to upload a simulation, and we're going to run out of time, so I'm going to have to be a little bit careful about how we handle this. But this is critical. What we're going to have is a set of demos. These will be zipped files. And you can get these either from the student materials folder. You could get these from the student materials folder, or we will try to email them to you beforehand. And so the first thing you're going to have to do is you're going to have to go to the Google Drive. Thanks, James. I'm sorry about that, but that can happen. And that's my best suggestion that is that if the state of CompuCell gets to be a pain, hit terminate and relaunch it. It only takes a few seconds. Hayden, are you there?
Yes.
Could you please put the link to the demo 1.1.2 in the chat?
Yeah.
The Google Drive for download.
Yeah, I'll have to open your slide. I don't have that one on hand.
Okay, I can do it. Okay. So I need everybody to download this file that I put in the chat. And you need to put it someplace where you have access to it. Make sure that everybody can do that. Okay. This will seem a bit cumbersome, but once you've done it once or twice, it's pretty easy. Okay, once you have that downloaded, I need you to go back to your dashboard in CompuCell, in nanoHUB. And besides CompuCell, the other tool that we will need is Jupyter Notebook. So go to All Tools, Jupyter. And you'll find Jupyter Notebooks and bookmark it and hit launch. So I want to make sure that everybody is able to find that. If you're working on a local system, you don't have to do any of this. If you're working on a local system, just download the zip drive, the zip folder, and have it local. This is only about uploading files to and from nanoHUB. Okay. So again, to get to Jupyter Notebooks, go to your dashboard in nanoHUB, search All Tools, Jupyter, open Jupyter Notebook, and bookmark it so that when you go to your favorites, you've got it available. And I would suggest leaving a copy of Jupyter Notebook running on your local machine, on your nanoHUB server, so that you have it available. This is important because this is something we're going to, if you're saying you're not finding the dashboard, hover over nanoHUB on the top right, top left, click there, that'll take you to nanoHUB dashboard. Or here where it says logged in, click on dashboard. Anybody else having trouble finding it? So again, go to dashboard. In dashboard, if you bookmarked it, under favorites, Jupyter Notebook. If you haven't looked at it, found it yet, go to all tools, Jupyter Notebook. Or you could use the link that I put in the chat. The link that I put in the chat for Jupyter Notebook. If you already have it running, under My Sessions, you can go here and reopen. Okay. How are people doing? Is anybody stuck, or does everybody have Jupyter Notebooks open? If you don't have it open, let me know. Okay. Once you're in Jupyter Notebooks, you click Upload. And now you will have to navigate on your local machine to wherever you stored that material. In my case, it would be actually where I put it for you, which would be Student Materials Demos, Module 1.1. In my case, colonic crypt, and you want to point to the zipped folder. So wherever you stored it, point to it. See, example colonic crypt.zip. And now I hit upload. In my case, I've already done the upload, but I'll do the upload again. And you'll see it here. Example colonic crypt. That's now uploaded that file to Jupyter, to your local space on them. Now I can go back, Jupyter Notebooks, from Jupyter Notebooks, I go back to my desktop, I find my CompuCell, and reopen CompuCell. Once I've opened it, I can now open that file. I can do that by going to File. I'll follow the method that I have here. We're going to go through CC3D main tool. We're going to switch to the editor. To switch to the editor, I hit this pen and paper icon here, or under File, I can go to Start Twitter. This is now the model editor. I now go to either Open File here, the up arrow, or CC3D Project, Open CC3D Project. I select my directory. I find where I uploaded it. Example colonic crypt. And I hit open.
So sorry, I think so the folder was compressed. Are you supposed to unzip it?
No, it will unzip itself when you select it.
Yeah, it's not working.
What's happening?
Oh, okay. Yeah, I've seen it here. Yeah, thank you.
It will unzip itself. You may have to hit an OK button to unzip it.
Yeah, thank you. It's working now.
Okay. I want to make sure that everybody can do this because we're going to be doing it a lot. Once you have it unzipped, you can double click on it, see the code. You can hit open in player. And I have to switch between the two tabs at the bottom. And now I have that simulation running. I can't find the CC3D file in the now unzipped folder. When you look in the unzipped folder, it may be one level down. So you may have it may unzip into itself, in which case you have to look inside of the open folder inside of the folder. So let's see about that. Stop. So let's see, I'm going to open the file. In this case, when it unzipped, where to put it? Here's my colonic crypt zip file, unzip it. It unzips it. And now, okay, I have to say where I want to put it. Put it here. Unpack it. And now it's unpacked it. And I should be able to open it directly. Open in player from Twit. Or if I want to go to player and open it from there, file, open simulation. Let's see, I should save sorted by name. Colonic crypt, it created a new replica of it. Go into colonic crypt, it may be here, it's example colonic crypt, I have to go down one to find the name of the file. Is that an error or a warning? You say you get an error message saying could not you. Okay, so then you could ignore it. Okay. I realize that this is cumbersome the first time we do it, but once we've done it once or twice, I think it won't be too bad. Okay, this is a review of how to unzip. Here it says you may get a warning, so don't worry about it too much. Open it. You may have to go down a level because it may have unzipped it inside of itself. Point to this .cc3d file. Okay. The only other thing that I wanted to say, because we're out of time now, is everybody able to open that file and get it to run? I guess that's the key thing. Let me make sure that people were able to get it to run.
Sorry, I
Yes.
couldn't find the file. I kind of lost. Which files should be uploaded?
Sorry?
Which file should be uploaded?
Well, in this case, I gave you a link to a file that you could download. But is anybody else having a problem with this at the moment? Yes. What's going on, James? What's going on for you?
Yeah, after the error message saying it couldn't uniquely find a .cc3d file. It's unzipped, but yeah, there is no .cc3d file within the folder that's now been unzipped. So
okay. The folder's empty, or?
Yeah, it looks that way, yeah.
Okay, it doesn't contain another folder inside of it.
No, not that I can see.
And if you try going up one level, what happens?
Yeah, the point where my username is, there's the .zip file, and there's also the folder.
Right.
And there's
Okay, well, it's possible that the file that I just uploaded was a dud. In which case, I would ask you to wait until we go to the, let me give you.
I just grabbed it from the link you posted and it worked okay for me. So I wonder if we're not looking at the same thing, maybe.
So why don't we try it all together one more time? I'm going to go to, let's see, where's my, I'm going to go here. Let's see. So I'm going to, could you put the link to that folder in the chat again, please?
Yes, I just posted it a second ago.
Okay, so let me do it myself. I'm going to hit the download. I'm going to hit the colonic crypt example, and I'm going to download it. And I've already downloaded it, so I'm not going to download it again. So, and now in nanoHUB, I'm going to go to upload. I'm going to select the zip file here, colonic crypt, hit open, upload. I'm going to overwrite the one that's already there. Okay. And it's here, example-colonic crypt. I'm now going to go back to my CompuCell. I'm going to go back to quit it. I'm going to hit open. And now I'm going to select example colonic crypt, and this is the one that I just opened. And it's here. And so it unzips and it gives me colonic crypt.cc3d. So I'm not sure what could be happening, but let's try to debug this during the break, okay? Because it's certainly important. Is anybody else having this problem? Yeah, the fact that somebody says they're seeing only 2 cell types, that's true. The configuration of the cell types is something that we're not going to have time to do right now. It was in fact the next step that I was going to do. The one thing that I want to show you though before we break, because we're going to be out of time, and I'm happy to debug during the break, is that I want to show you 2 things. One, to switch between Twidit and Player, you use the tab buttons at the bottom here. You're going to be doing that a lot. If you have only Player running, you can start Twidit from this button here, start Twidit, or under the File menu, start Twidit. If you have only Twidit running, you can start Player by hitting, in this case, the blue icon. It's grayed out because Player is already running, or right-clicking and saying Open in Player. That's a way to get back and forth. The other thing that I wanted to show you is that if you're in Player, you can go to CC3D project, select zip it, and that will allow you to save a zip version of whatever you are editing now. And then, as before, you would go back to the Jupyter Notebook, and here I can select, I need to find a zip file here. I can select a file and I can download it by visiting the download button. And so that you can zip see more cell types, it's very slow. Good. I'm glad people who are caught up are playing. That's good. So for downloads, you will zip your file into it, select the file name, and then you would hit, and I can't do that because it has to be a file. I would select the file name here and then hit download. Okay. Okay, other questions, other problems? Sharon, what's up?
I just can't get there. I had the zip uploaded into Jupyter and clicked on that, and it just gave me an error.
No,
And
you
then-
can't open it in Jupyter because
Okay, where?
it's not.
Okay, I
So-
asked him in the chat a couple times, how do I open it?
Okay, so you've uploaded it to Jupyter. No, you've
Yeah.
uploaded it to nanoHUB.
Yep. Well, I've uploaded it in Jupyter and nanoHUB, yeah.
Right. Well, all we're using Jupyter to do is like an FTP to move the file from your local machine to the nanoHUB server.
Okay, that's what I was wondering. So go back to CC3D.
Yes. Now go back to CC3D,
Okay.
and it doesn't matter whether you're in Twit or Player, whichever you have open.
Okay.
Whichever, if you're in Player, are you in Twit or Player?
Player.
You're in Player. So let's do it from Player. Okay, here's Player. I go to Open Simulation File. I find my simulation file. This happens to be the one that I just uploaded, example colonic crypt.zip.
And where will it be? Oh, there it is. Yep.
And I hit open.
Could not uniquely identify a CC3D project.
That's fine. So I hit OK.
Okay.
And now it will unzip it when I do that. And I select it again. Example colonic crypt. Hit choose.
Let me see what happens. Go back to file open simulation file. Oh, yes. Okay, and maybe I got it, except it's not opening anything obvious. Let me try
No,
this.
you cannot unzip locally and upload after unzip. You can only upload single files. So you have to zip before and after uploading. Okay.
Wait, say that again. I have. Yeah, I mentioned it up in the chat that I tried that, but
Okay.
that's fine. But I've
Okay.
I found the zip file in CC3D.
Right.
I clicked on it and
Yeah.
then went back to the file viewer again, and this time found where is it again? A folder that I guess
Right.
got zipped. Went into
Right.
the folder
Right.
and clicked on example colonic crypt, which is also a folder. Actually, maybe that's.
Sometimes it'll unzip inside of itself and then you have to go down one.
Yep, and then I found colonic crypt.cc3D,
Yeah.
which did open actually. I have that
Yes.
open,
Great.
but it's blank. Okay, try run. Does anything happen? Oh yes. All right, I'm there. Never mind. Oh, just crashed. But that's typical.
That's that one we can work on later. Or at least it could.
Yep.
Everyone else, I realize that this is traumatic, but it gets easier, I promise. Anyone else? Okay. So again, the other one that you need to know about, and I'm going to skip the exercise that we were going to do here, is downloading. And again, for downloading, I need to go to Twit. I hit CC3D project, zip it. That will allow me to zip it, the file. I'm going to give it a new name so I don't overwrite one I already have. Zip it and save it. And then I go back to my Jupyter notebook. I find the zip file that I just created. And since I've created a lot of them, here it is, example coloniccrypt.zip. Hit the tick box to select it. And now I hit download. And that will download it. Okay. So why doesn't everybody try doing a quick download that way? Try that. Somebody says they need help. If they need help, raise your hand.
Can you show that again? The part where you download on your local computer.
Okay, so to download to my local computer, I go to Jupyter. I select the file that I want to download. It has to be a single file. I cannot download a directory. In this case, example coloniccrypt.zip. I scroll up to the top and I hit download. That's all I have to do.
Got it. Got it. How did the file reach the Jupyter though? Because we just uploaded that. Do you not have another file which is already there, which you ran on CC3D and then it came to the Jupyter notebook?
So in CompuCell, in Twit, I go to CC3D project, zip it, and then I give it a new name. I gave it the name Crypt3 so that it would not overwrite the file name that I already.
Yes. Yes. Okay, I got it now. Thanks.
Yeah, maybe I can quickly help clarify. You have one single hard drive storage space on nanoHUB that all apps on nanoHUB access essentially. And what we're doing is we're just using one app to create a file in that shared storage, which you can then access through other apps. So we're not necessarily sending these things back and forth between apps. We're sending them to a shared storage location that the apps both access, if that helps clarify what's happening here.
Yeah. Now it makes sense. Thanks.
Okay, great.
Okay. So that was everything that was urgent to do. There's some more material that I would be happy to present, but we've run over time. So I'm going to close this session. I'm going to close the session by launching what you will get after every session, which is a module experience questionnaire. And I do ask people to fill these out. I realize that sometimes things don't work, like today. Sometimes we have internet problems. Sometimes the Zoom crashes. Sometimes nanoHUB will crash. Sometimes the slides aren't good. And so we really do appreciate your feedback. And we look at your feedback for these module experience questionnaires, and we do try to adjust the speed and detail with things, which we do things. So I do ask that everybody fill these out, please, for us. And we will end every module with your feedback, and we do log all of that feedback. And sometimes there isn't time to take it into account for the same day, but in preparation for our future modules, we will always look at what you suggest. So we do ask you to fill that out.
I have a problem. I save it on nanoHUB, but it doesn't show in Jupyter.
So then the question you have to figure out is where you saved it. So nanoHUB is a Linux operating system, and so it has its own file structure. When you do your save within CompuCell, you can select the directory you save into, and similarly within that Jupyter notebook navigation tool.
Oh, I found it.
You can move up, down. Here for navigation, I can navigate here through the directory hierarchy.
Yeah, it was inside another file. I found it. Thanks.
Okay. Any other questions? Yes, please go ahead.
Yeah, when I open Grid and I click on simulation, It is opening a blank file, CC3D simulation, meaning even if I zip it, it will not show in the Jupyter because it's a blank file.
I'm not sure what you mean. If I go to CC3D, quit it here, you have a name
So,
file here, Polonic crypt.cc3d.
no,
So you have nothing open. Is that
I
right?
have two columns, CC3D project and CC3D simulation, but inside that there is nothing. So should I open some file?
So again, if you're in Twit, you want to open a file, you have to select the file that you want to open. So here I could open cancer demo, for example. You'll always open something that has the CC3D affix. When I open it, it will open it, and I will be able to see that simulation.
I will open the crypt file in the.
Okay. Okay. Anybody else? Please do fill out the questionnaire. Give people another minute or two for that.
I see the same window like this one, but I can't find the run option here.
You can't find what?
And the run option. Where to run this file? How to run
To
it?
run the file?
Yeah.
If I want to run the file, I hit right click, open in player.
Okay. I got it. Thank you.
Anyone else? You'll have plenty of practice, but the more debugging and pain we get through now, the easier it will be later. And only 37 people have responded to the questionnaire, so please do respond.
So Jocelyn has a question too, but I think we should probably move on to break for people who are finished because we're a little bit behind schedule now. So
okay, so we will stick around to help debug, but this is the end of our official first lecture. I know it was rough, but I hope things will get easier as we go forward.